Hello everyone, I hope you're doing very well. This is Ali Reza, and in this project we're going to build this PID test bed, and after that we're going to program it everything from scratch, and we will learn how each component of a PID controller affect our system. If you have any questions during this project, leave comments and stay tuned. Okay. The initial step of this project is to design an initial sketch and then draw your 3D design based on this initial sketch. First, you need to know what we are going to work with. This is a setup for a PID controller. So we need to have an LCD and then 4 potentiometers or volumes, because we need to set our 4 different set points, P, I, D, and set point for the angle. And then we need to have an actuator like a motor with an arm or a hand to show the exact angle. Then I try to make a very simple sketch. So something like this. And there should be a very tight slope here, like 45 degrees, around 45, because imagine that you are looking at the setup from here. Then like this, I try to do my best. Okay, this is a very simple sketch, and imagine that here we need to have a switch or push button to apply the changes, and here you need to have an LCD to see the values, both the end point, like here, the exact angle, and here you need to have one volume or potentiometer to set the desired angle, and here for P, for example, I, and D. So we have 4 potentiometers, maybe 5 or 10K potentiometers or volume, and this is an LCD. Then here there's the shaft of the motor, and for example, you have something like this as an arrow or a hand showing the angle from 0 to 180. And here you need to have a USB port, because the Arduino is going to be installed exactly here. And on the back side, imagine that this is the back side. You're gonna need some ports also here, something like a rectangle for the on-off switch, and another one for your power supply, maybe a T connector or whatever you're going to use. And also you need to have a ventilation part right back, like here, because your motor driver is going to be installed exactly here. Okay, this is just an idea, just an overall idea of your system. Then you need to transfer everything from here to 3D designing software like SolidWorks or like Fusion 360. But remember that an important step is to measure exactly, for example, the distance between these 2 screws, or even the size of the entire module. This is the driver, L298. You will use calipers for this purpose. For example, this is 43, roughly 43 millimeters, and you can set 45 millimeter or 44 depending on your 3D printer accuracy. And remember, you have to measure here and also the screw points. Okay, so you need to measure everything. Also for the Arduino, wherever you're gonna screw, like these 2 points, also these 2 points in the back point of Arduino, and also your LCD. And if you want to know more about this caliper, you can watch the video I prepared for caliper. And also these volumes, potentiometer, I'm going to use these 5K volumes, they are linear, and they should be linear because otherwise when you want to adjust them, it would not be that much easy. And you also need to measure this point because this part of the volume is going to come out of these holes, and also your motors. Then you can write everything on a piece of paper, like what I've already done, like this. And for example, this is the part related to the switch. This is like a toggle switch or push button to apply the changes you have done here to the system. For instance, you set it to like 45 angle and you set PID to whatever you want, and then click on this switch. Then it will be applied to the system and you will see the result right here. The motor will move from 0 to 180, exactly what you've set here. And then this is the LCD. This is just a very simple sketch with some values I measured, and then I transfer everything to Fusion 360. Then let's go to the next step. Okay guys, this is the last version of the designing. This is the front side and this is the main box. And here you have a place to press in your switch with which you can apply the values of these 4 potentiometers to the system. And here this is your LCD, your gearbox. The motor can be installed here, either in this direction or this direction. And this is the holder for the feedback volume, will be installed here, and the coupling and the gearbox motor all will be aligned. And in the main box you have on-off switch, power supply connector like T connector, and this is a ventilation part for the heatsink of the motor driver, and your Arduino will be installed here, so we have a USB port right from here. And that's all. So the next step is to 3D print these 2 parts. The first, this is the first thing that I'm gonna print, and then the main box. And of course, if you think that you are right-handed or left-handed, so you can mirror this part. So the volumes will be here or here. I think I will mirror it along X axis, so it would be easier for me to work with. And I come to this part and export. Then you can select the location and the format, the extension of your file, which will be STL because I'm gonna use 3D printer slicer. So STL is the thing that is the extension and the format that will be used for my slicer software. And then I export because I already have it. Then everything is done. Okay, now we have this 3D printed part. This is the front side of the box. I've put one of the potentiometers here. You should be careful because there's a small hole, and you should fit your volumes exactly in this direction to fit it one by one for all 4 volumes. And this part is for your switch, this switch. So you can apply the values of these 4 potentiometers to the system. And here's your LCD. You should put it like this. I think the correct direction is like this because you need to see the words in the correct direction. And then you have some screws here to screw your LCD to the panel. And here you have your motor, the geared motor, so you can screw it down like this or like this direction. And then you have coupling, 3mm and 6mm. So 3mm goes to this one, to the shaft of your motor, and then you have screws. Another part, another side, 6mm for your feedback volume, and then you screw it down again like this. But you need to be careful that it must be placed like this, and after that you need to insert your volume. I think you can see it right now. But before, you need to work with these nuts and screws. You have something like screw and then a knot to keep it tight here. So first I'll put this here, and then also you have some washers. Then you can screw it down. Okay, so let's do it all and then go for the second part of this 3D printed box. But there's a problem, there's a very small problem here. I designed this box, this 3D printed part, using the datasheet of this motor, but when I received it, these holes are not 2 millimeters. I mean, in the datasheet it was 2 millimeter, but now I can see that they are smaller than 2 millimeters, so I will just use some glue for this motor to keep it here, rather than those 2 millimeter screws that I designed based on the datasheet. I think there's a typo in the datasheet, or maybe, but that's not so important, so I just go on with these glue technique. This is my LCD that I want to use in this project. It has 2 rows and 16 columns. And if you see here, you need to work with a lot of wires, a lot of connections. So I work with these converters, so I can work with I2C communication or I2C communication with my Arduino. It has only 4 wires. Of course, 2 of them are power, so VCC and ground, and the other 2 are the only wires that I can use with my Arduino to make a connection between the Arduino and the LCD. So instead of using these, I don't know, maybe 16 connections, I can use only 2. But I have to solder it here, so let's do it first and then the other parts. Okay, now we have the main box. We have to remove these supports, also for backside. So you must be able to remove these supports easily, but if it's not like that, there is a problem in your configuration and setting in your slicer software. Now I'm gonna solder this T connector and the switch. You should be careful because you need to place it in and then solder it, otherwise you will not be able to do so. So I just solder the other pole of this T connector, and then after placing it in, we can start soldering to this switch. And then I will solder the red wire, the short red wire. I think it's clear here. The short red wire to this one, this pin of the switch, and another long wire to the other one, the upper one. And then This would be the power supply cable of the main circuit. Okay, so far we have the front side, LCD, volumes and switch, and the motor, gear motor, and you can see that the coupling has coupled the feedback volume and the DC motor, and I've also soldered the I2C converter and the LCD. So, and also here we have the Arduino and the motor driver, T connector power supply and on-off switch. And the next step is that we need to solder the positive and negative, I mean the VCC and GND pin of these. For example, this one, the feedback volume, and the other four input volumes together. Imagine that the left side and the right side are for power supply. For example, left side is positive VCC and right side is ground. So for all of them, I'm gonna connect everything like this. The left side to the left side to the left side of the next one, and so on. Also for the right one, this is the right side, right pin. It means it's VCC, 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 and so on for the other. And the middle pin is the output pin of each of these volumes, meaning that the signal coming from the volumes go to the analog input of the Arduino. So this must be different for each of these volumes. I'm gonna connect the, for example, the left one to ground, GND, so I use black, and the right one to VCC, so I use red wire for them. And later for the middle one, which goes to analog inputs, which is the output of these 4 or 5 volumes, with another color. So let's solder all positive and ground pins. Here we have the complete setup, but before programming, I gotta tell you some very important note. Arduino Uno has 6 analog inputs, as you may know, from A0 to A5. So we have 6 analog inputs, and we can also use 6 volumes, for example, one for feedback, one for set point, P, I, and D, and also another one. But the problem is that here we are working with an I2C communication board for the LCD, which works with I2C or I2C communication pins on our Arduino, which is SCL and SDA, which we have here. Okay? And the problem is that A4 and A5 on each Arduino Uno board is dedicated to I2C communication. So if you're gonna use one of them, for example, you're gonna use 6 or 5 analog inputs, then you will not be able to work with I2C LCD or whatever which uses I2C communication. And vice versa. If you're gonna use I2C, then you will not be able to use these 2 analog input pins. So you only have 4 analog inputs. For this purpose, I had to reduce the number of volumes. So we only have one feedback volume, one P, I, and D. And the set point is not going to be set from this volume. So this one is useless at the moment. And even if you're going to use these separate I2C pins, SCL and SDA, and if you're not going to use these 2 pins, no matter, because they are interconnected. And either you use these 2 or the separate pins, they are connected to each other, and these 2 will be useless for you. Maybe in the future we can change our Arduino to something like Arduino mega, then you will be able to work with more analog input and also separate I2C ports. And that's all. Let's start programming and test the values for our 3 gains for the PID controller. I have to close this part. And screw it down using M3 screws. Okay, now everything is done. I also programmed the device. I want to try different values for P, I, and D and see the result when I click this button. You can see the result here when the arm is moving and also on the screen using the serial plotter of the Arduino. Then first of all, the proportional gain is 1, integral gain is 0.2, and derivative gain is 0.3. The current position is 88. Then let's see. We have some oscillations here. Maybe after a couple of minutes or even a couple of seconds, you will see that it will be stable, and maybe not. You need to tune it. For example, it's okay. And I'm gonna increase the value for integral, for example, to 2, and then C. You can see that it's a little bit better. Then increase it a little bit more, like to for example, 2.5. A little bit more to see the result when it's like 3. You can see that it's a little bit worse than before. It took much more time to reach the stable point. By the way, pay attention to this position. Now let's increase, for example, P, proportional. It make it a little bit faster. Set it to 2. You can see that it's by far better than the previous values. I set it to like 3. Worse. By the way, you need to tune it to get the best result. Increase or even like decrease the value for I and increase D a little bit. For damping, so it's somehow better. Increase a little bit more. So it's worse. So now you can see that the result of a proportional gain, integral gain, and derivative gain. It will make the system faster. It will cause some oscillations if it's too much for integral, and also It depends on the oscillation of the system. And also the last one, which is derivative, will damp the system more or even less. So using this test bed, you can see the effect of each of these three components of the PID controller and on your specific system. I hope everything's fine, and if you need anything, any more detailed explanation, or if you have any questions, just leave us some comments and subscribe to our channel for more videos.